As soon as we hear functional programming, it might sound a bit scary, and to be honest, it can be. Just kidding. But don't worry, by the end of this video, you will see that it's not as daunting as it seems. So let's get started. Today, we will be covering 4 key concepts, namely pure functions, immutability, currying, and memoization. Pure functions. Imagine if every time you made a sandwich, it was exactly the same sandwich. That's what pure functions do. Here the given function is impure, not because the functional name is impure, but it modifies an external state counter. Another reason being, its return value depends on previous calls, not just its input. This makes it unpredictable because the same input A might not always produce the same output. Now what has changed? The function now only depends on its inputs A and B. It doesn't modify any external state or rely on previous calls. This ensures that for any given inputs, the output is always the same, making the function predictable. Immutability. It's like sealing your data in a time capsule. Once it's in, it never changes. So what's happening here? We are directly modifying the person object, which can lead to unexpected state changes across the application. This can cause issues if other parts of the code are expecting person.name to be Alice. Now what has changed? By using const, we ensure that the reference to the person object cannot be reassigned. The spread operator creates a new object, new person, with the same properties as person, but with the name set to Bob. This approach keeps the original person object unchanged, promoting data integrity and making state changes explicit and trackable. Currying. It's like magic. You can make functions that return other functions. So what's happening here? This function takes 2 arguments at once, which is a straightforward but not flexible for partial application. So now we follow the currying concept. What has really changed? The function now returns another function. This allows for partial application. For example, curry multiple, which takes an argument as 2, returns a function that multiplies any number by 2. This is useful for creating specialized functions from more general ones. Memoization. It's like having a wizard who remembers all your spells so you don't have to cast them again. So what's wrong here? This function calculates Fibonacci numbers recursively, which is very inefficient for large numbers because it recalculates the same values multiple times. So how can you fix this? Now we have wrapped the Fibonacci function with a memoize function. Memoize creates a cache to store results of function calls. When the same arguments are passed again, it returns the cached result instead of recalculating, which significantly improves performance for repeated calls or larger numbers. And there you have it, folks. Functional programming in JavaScript isn't just about coding. It's about making your code smarter, safer, and more predictable. If you enjoyed this journey through the magical world of functional programming, hit that like button, subscribe for more, and let's keep coding with a smile. Goodbye.